Welcome back everyone to another video, and in this one we'll take a look at how the hell one of these things work. They are called boogie pads or just LCD pad and stuff like that. It has a couple of years of battery life. You get a writing pen. It's super light, like there's no weight to it. So how does it work, and is it actually LCD or is it one of those mm, magnetic fluid thing that have tiny ferrite powder suspended in it? We'll take a look at all of this and let's get started. So these things are called boogie pads, as I said, and let's see how they work first. So it is slim as all heck, and like there's no width to it. There's actually no electronics component on it at all. So just wanted to see and show you all how it actually works. So you've got your pen and you can write stuff on it. So GTIH, and like you can see it's visible. It's better visible in bright light than in dim light. There's no backlighting to it, and you can scribble stuff any way you want, anyhow. And to clear the screen, you just press this button and it goes away. So now if I do this again, and if you notice it carefully, when you press that button, the screen actually flashes for a few seconds and then clears itself out. So the press a button to clear the entire screen kind of reminds me of those old writing pad we had as toys with that actually had like a ferrite fluid in it, and when you the pen had a magnetic core, and when you touch the pen to it and the ferrite will get attracted to the upper layers, and then you have a magnet at the bottom that would clean it out. There's no magic in this pen. Actually, I can just use my fingernails just as well and it will work, and still clear, still everything works. Then it also kind of reminds you of an e-ink display where it actually requires a full screen refresh to get things off the display. Some of the older ones needed to do that. Some of the newer ones can do partial refreshes, but that's very limited. But yeah, so how the heck does this work? Is it actually an LCD? Is it what they claim? And you cannot take any data out of it. There's no microcontroller on there. There's literally nothing, no microcontroller on there at all. No programming involved. So this is what they call Cholesteric. Let me just get that pronunciation correct for you guys. Yada yada yada. Cholesteric liquid crystal displays. So how that works is it will take your pressure, and that is what flips the crystals in the liquid. And in regular LCD you provide a certain amount of voltage that will flip the direction of the liquid of the LCD crystals, and that would then bend the light according to how much you need to be bent. Similarly, here we are not providing it electricity, we are providing it pressure. So if you have very light pressure, it wouldn't turn that much by that many degrees, but as soon as you start adding pressure, it turns by higher degree, and that then bends more light and allows more light to reflect off of the green background, and then that gives you the green color of it. So but there is electricity involved. You press the button and all of it goes away. So why can't you do it to a single area? Why can't you just remove this line? Well, because this entire thing, it's a complete single pixel. This is what I like to call analog LCD. So there's no digital divisions, there's no units, there's no pixel 0, pixel 1, pixel 2, pixel 3. This entire thing is a single pixel, and you can still accurately write what you want to write, similar to old computer monitors where it was just a old like oscilloscope monitors and stuff like that, where There even wasn't like a mesh, so the beam would directly hit the phosphorus coating on the glass. So you had almost unlimited or unlimited number of points you could hit. And similarly here, there's no division within the LCD. It's one single huge pixel, and wherever you put pressure, it just switches that area, so it's completely analog. And I've not seen that term used before for these things. I've seen various articles that are confusing it with, oh, it has multiple electrodes, and where you push it, the electrode gets active. No, there's no electrode in there. There's just one single piece or two pieces of metal, and when you press that button, they get energized and clear the display. That's it. There's no other electricity going on there. The battery is just to clear the display, so I can take out the battery. There you go. And I can write on it, like it still works. There is no electricity involved with this, but I cannot clear it because, hey, there's no charge. So I have to put the battery again. But enough about clearing it up. I want to see what's inside it. Um, how does it actually look like? So just to show you guys that battery is just for clearing, I'll put the battery back in. And the cover is kind of broken, like it's not that of a good quality board, but and these things are like stupid cheap. There's no point buying the more expensive one. So yeah, as soon as I put in the battery, press the button, it clears everything out. So let's open this up. It will be destructive, that's why I have waited so far and never attempted um, to uh, to tear it apart, because I wanted to save it for this video. So it's all glue. um, the best way you can do is jam something in there and hope it will pry out. um, and you could use hot gun and all of that stuff, but I really don't want to. So just tons and tons of glue is what is holding it together. And you can see, as I will remove this, the LCD will start changing color. And there is the LCD itself right there. So it has already started to change color because there was a difference in pressure. And if I go all the way through, I can just strip away most of it and revealing the electronics here. So nothing programmable, just one single button, and that's it. So it was fairly well stuck. It might have destroyed bits of the LCD. So you can see you have your positive and your negative right on top of the LCD. These electrodes, and then you have your button and some more electronics that are all hidden away. So if I attempt to take that out as well, there is a screw, but I'll take out the cover first. Or is it a flex PCB? I think this might be a flex PCB. No, it's not. It's not. It's a regular PCB. So yeah, that reveals two screws. Don't have the correct fit for it. There you go. And that brings out the entire assembly, and you can basically flip this over or not. But first, before I let that out, I actually want to see how all of the sides, if there is any damage on the sides. All right, and there you go. So it clears out everything, so it's still functional, which is good for us. And I'll take that out again. And there we go. um, the entire LCD lifts up, So you can see one of the electrodes is going on the back. The other one, much like a regular LCD, is a clear electrode, and that's going in the front. And again, wherever you put even the slightest of pressure, it will, so you can see the edges have turned because I was holding it from there. If I hold it from here, the edges will again change color. And there you go, there's the film on the back for your electrodes. And so just a boost voltage, I'm not sure, it's like 20 or some odd volts. Um, and just let's see if I can register that. um, Good as new. As soon as you press that, good as new. So yeah, it's not experimental, because if it was a experimental device, I would have seen patches still remaining. But as soon as I pressed the button, as soon as there was that jolt of electricity, it just cleared itself out. So completely. So I think it's pretty good. I don't think it should be limited to this particular use case. There might be more people can explore, because I'm not sure if you what happens if you reverse it. Will it actually, can you actually write stuff on it? Is it like phosphorus? If I put an electron beam through it, will it work? Or all that sort of stuff. Is it possible to actually use it as a viable dynamic display, not as just a writing pad? So yeah, on to the voltage. So I'm guessing it's DC, and completely ignoring the positive and negative because there's nothing telling which is which. And let's hope for the best. Nothing. It didn't even register slightly. So that clears out, but it shows a constant negative voltage for some reason, but nothing when I press it. Oh, so see a high. So I keep pressing it, will be on the reset mode, and it reached that overvolt protection symbol for a second, and then that was gone. So it's way more than this meter can handle, obviously. It went up to 43 volts DC, and there was the lightning strike thing that indicated it was going overvolt over the meter. Yeah, that's it's basically how that works. It's all pressure sensitive. Um, there's no point putting it back together. It's already lost its charm and its adhesive properties. Um, yeah, so I guess it's kind of okay, but in the day and age where tablets are so much cheaper, um, even for use as a you know to take orders in restaurants and stuff like that, you would still need something to be able to copy and show in the kitchen. And like it barely makes sense, maybe taking quick notes, but then why won't you just take it on paper and have it with you at all the times other than just erasing it? So I guess I have sort of mixed feeling about that, but hey, here it is. It's a cool tech, an analog LCD, and thank you so much for watching. I hope everyone enjoyed this video, and I will see you all in the next one. Till then, it's GTIH signing off. Completely missed that up. There you go. Bye.